Hey guys, welcome to my channel, the Tech Coders, and today we are going to solve question number 19 of Leetcode, that is remove nth node from the end of list. Okay, so question states that given the head of a linked list and we are supposed to remove the nth node from the end of the linked list and return its head. Okay, let's understand with the help of this first test case. So 1, 2, 3, 4, 5 was our linked list and we were supposed to remove the last second node. Okay, so after removing the last second node, this was my answer, that is 1, 2, 3, 5, 1, 2, 3, 5. So this is what removing last nth node means. Okay, so let's move to the solution part, and over there we'll discuss what will be our logic and approach to solve this question. Okay, so see, we can solve this question by two ways. Okay, so let's discuss the first approach. So this is my given linked list and I have to remove the last third node. So what will be my answer after performing all the operations? It should be like 1, 2, 3, 5 and 6. Okay, this should be my answer. So now how I can proceed? I'm saying that initially I will try to find the number of nodes present in my linked list. And how I can do that? I'll take a temporary node which will initially point at head, and I'll try to keep on jumping to the next node until and unless next is not null, until and unless the next of temp is not null. Like this. See, I'll jump to this, 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 and now this node's next is null. This means that this is my last node. Okay, this is my last node. What's the count of n? Initially the count of n was 1, then 2, then 3, 4, 5 and 6 over here. Okay, so now the count is 6. Now I have to remove the last third node, that is this is this is last node, this is last second node, and this is last third node. So I am intended to delete this node. Okay, so now see, this node's next is this node. What I'm saying is that third node's next is this node. So I'll change the next of this node to directly this node. Okay, try to get my point. I'll change the next of third node to the fifth node, and after changing that I can see that this link and this link will not exist, this link and this link will not exist, and when we'll traverse, we'll directly go from third node to the fifth node and then sixth node and out of my iteration. Okay, so now how I can change the next of this node to this node? Let's see that. Again, I have to reach this node, that is the third node. I'll again declare my temp as head and I'll keep on jumping. From here I'll come to here, from here I'll come to here. Now the question is how many times I have to jump. Now the question is how many times I have to iterate. So I have to iterate c minus n times. That this means that I have to reach c minus nth node. C minus nth node. What's the value over here? 6 minus 3, which is equals to 3. That is, I have to reach third node. So now I'll do a very simple thing, that is temp. I have to change this node's next. So temp dot next is equals to, now see, currently this node's next is this and this node's next is this. What I'll write, temp dot next is equals to temp dot next dot next. Try to understand why temp dot next dot next. Okay, this is my temp. Okay, I have to change my next to this point. So temp dot next is this and dot next is this. This is my temp dot next is this, and then its next is this. That's why I wrote temp dot next is equals to temp dot next dot next. Okay, simple. So after performing this, what will be my answer? It will be like this: 1 is pointing to 2 is pointing to 3, 3 is pointing to 5, and 5 is pointing to 6. Okay, simple. Now I have successfully removed my last nth node, that is my last third node. Okay, so now we are done with this part, which we have already discussed in this previous video. Okay, so now let's move to another solution. So now see, in this approach we'll have two pointers, that is over there we were having temp, here we'll have slow and the fast one. Initially both slow and fast will be here. Okay, both slow and fast will be here. So I'm saying that I'll keep on shifting my fast to its next node for n times. So initially I'll be over here. Okay, then I'll come to this point, then I'll come to here, and then from here I'll come to here. Okay, I have performed jumped for 3 times, that is n times, 3 times. So now see, after performing this, my fast is over here. Now what I'll do, I'll shift my slow to the next by 1 time, and now I'll shift my fast to the next by 1 time. Okay, both 1 time, but slow will start from here, fast will start from here. And how many times will shift? Until and unless fast dot next is not equal to null. Okay, I'll keep on shifting my fast to next element until unless I'm not getting fast dot next is equals to null. Okay, so let's do that. My slow will come here and my fast will come here. My slow will come here, my fast will come here. Okay, now this is my last node because this node's next is null. So now I'll stop iteration. My fast is here and my slow is over here. So see, I have to remove my last nth node, that is my last third node. This is my last node, this is my last second node, and this is my last third node, that is the nth node. Okay, that is the nth node. So what I'll do at this point, I'll simply do one thing. I'll change this node's next to this one, as we done in the previous approach. What we'll do, we'll simply change this node's next, that is close next to this node. So how I can do that? As we have done in the previous approach, like this. Slow dot next will be equal to slow dot next dot next. Simple, nothing else. Okay, so now this link will get breakdown and this link will get breakdown, and my 3 is directly pointing or linked with my 5th node. So yeah, now if I'll iterate from over here, that is from head, my answer will be, I'll go to 2, I'll go to 3, now from 3 I'll directly go to 5, and now I'll go to 6, and this is my answered linked list. Okay, so what's the difference between the first and the second approach? Over here we are not supposed to find the length of our linked list, that is, we are not supposed to find the length of our linked list. That's it, nothing much. Okay, so now let's move to the coding part and we'll solve over there. Now try to get my point. There will be a situation when I'm supposed to remove my first node. When I'm supposed to remove my first node. Let us suppose that instead of 3, it was given 6 over here. So what will be my last 6th node? This is last node, last second, last third, last fourth, last fifth, and this is my last 6th node. Okay, so now see, what I was doing in my first step, I was changing my fast to its next for the n times. So now see, I'll come to here, this is 1 time, I'll come to here, this is 2nd time, I'll come to here, this is 3rd time, I'll come to here, this is 4th time, I'll come to here, this is 5th time, and then I'll come to here, which is basically a null, Okay, so now I can say that when I'm supposed to return the first node, at that time, after performing the first step, my fast will be equal to null. Okay, and if my fast is equals to null, at that time I'll simply return. How we remove the first node? What we do to remove the first node, we simply do one thing, that is head is equals to head dot next. That is, this was my head and I'm changing my head to this node. Okay, so this is what we have done over here. So what we'll do, we'll simply return head dot next. Okay, now we are done with all the concept and the parts over here, and now let's move to the coding part. See, we'll code the second approach over here because we have seen how to reach the last kth node and one node prior to that node in our previous video. Okay, and now we'll see how I can change my next to the next of next. So if you combine that video and this approach, you are going to code the first one, but it is important to learn new things. So we'll proceed with the new approach, that was the second one. So over here we were having 2 pointers, that is the slow and the fast. So let's code for that. What was my first step? I was shifting my fast to its next for n times. So let's code that. For I is equals to 0, I is less than n, I plus plus. Simple. Fast is equals to fast's next. Now I came out. What I said, that there will be a situation when I have to remove the first node. So what will be case at that time? In that case, my fast will point to null. So after this, what we were doing, we were simply shifting our slow and the fast pointer to its next element until and unless my fast is not null. So while fast dot next, simply change slow is equals to close next and fast is equals to fast next. Yeah, now we are done with this. After performing this, what we were doing, we were changing the slows next to the next of next. How I can do that? Slows next is equals to slows next dot next. Okay, now I have removed my last kth node, that is last nth node. Now simply return the head part. Now simply return the head part, and now we'll try to code it, run it. Sorry, it will be capital. Again, my bad. Should be like this. Sorry, guys. Yes, now I can see that all the tests, all those 3 test cases are passed. Now we'll try to submit it. So yeah, it is submitted too. So yeah, this was the solution, guys. I hope you understood all the logic and concept over here. So if you really understood all the logic and concept over here, so please like our video, subscribe our channel, and share this with your friends who are participating in all this code forces and Leetcode round. Okay, so thank you for watching, guys. Have a good day.